Okay, so we've seen how we can convert between moles and mass, and we've seen how we can make stoichiometric ratios to figure out how many moles of something there's going to be based on the moles of what we have and what we know. The question now becomes, how do we write chemical reactions and balance those? And the problem with this is there's really no straightforward procedure I can give you that's going to work in every single case for this. They're really more kind of like little puzzles, and sometimes you kind of got to guess and check a little bit. And it's just not always super obvious how to do it. In really complicated cases, I even sometimes go with like a numerical method using like Excel or something. But I can give you some primer on how to do this a little bit. So in the end, we're trying to make sure that we have the same number of each type of atom on the left-hand side as we have on the right-hand side. Same number of reactants as we have products. So the first thing I like to do is write out the reaction. This plus this is going to go to this and this. As far as what is going to be made, well, you guys really aren't at a point where you can predict that, so you're going to be told that in any one of these cases. And I don't put in any coefficients yet. And I just list out how many atoms I have on each side. So on this side, I have 4 hydrogens. There's 3 here and 1 here. I have 1 phosphorus. It's right there. I have 5 oxygens, those 4, and this one right here. And I have 1 potassium. And if I come over here, I see that there are 2 hydrogens. They're on the water right there. I have 1 phosphorus right there. I have 5 oxygens, these 4, and this one right here. And I have 3 potassiums over here. So the first thing when I'm looking at this is I say, okay, my oxygens are already balanced. My phosphorus is already balanced. What I don't have balance on is the potassium and the hydrogen. So I will just balance one of those first. Let's try balancing the potassium. Okay. And I'm going to do that by putting a 3 out in front of KOH. And then I refigure out how many atoms I have on this side. So now I have these 3 hydrogens and these 3 times 1, 3 hydrogens from 3 KOHs, and that's a total of 6 hydrogens. I still have the 1 phosphorus. I have 7 oxygens now. I have these 4 here, and 3 times this assumed 1 subscript here, 7 oxygens, and 3 potassiums. So now what I balanced my phosphorus, I balanced my potassium, but now I got my oxygens out of whack and I got my hydrogens out of whack. But I will notice that I have less hydrogen than on this side than on this side. And I have less oxygen on this side than on this side. And so what that means is that I should change this H2O, okay? Because that one has oxygen and it has hydrogen only. And so I can change this coefficient, and I will change just these 2 values. Now, what do I put up there? So I have 1 oxygen right now. If I put a 2 up here, then I'm going to have 2 oxygens, and this is going to be 6 oxygens. So that's not it, okay? I need to put a 3 here in order to have 7 oxygens altogether on that side. Then I will have 4 plus 3 times this 1, 7 oxygens. So once I multiply the H2O by this 3 here, I start adding up my reactants and my products, and I see that I now actually do have the same number of atoms on this side as I do on this side, and this is now a balanced equation. Let's go through another example here. And this one's going to be kind of a hard one. So we have copper solid. We're going to react that with nitric acid. We're going to produce copper nitrate. We're going to produce water, and we're going to produce nitrous oxide gas. So we got parenthetical stuff here that we have to deal with, polyatomics, all that kind of stuff. The first thing we're going to do is we're going to add up our number of reactants. So we have 1 copper, we have 1 hydrogen, we have 1 nitrogen, and we have 3 oxygens. And then on this side we have 1 copper, we have 2 hydrogens on our water, we have 3 nitrogens. So we have 2 times the 1 that would be assumed here. So that's 2 nitrogens from that, plus the 1 in the NO, and we have 8 oxygens. So that's 2 times this 3 is 6 oxygens from here, plus this oxygen, plus this oxygen. Now, if I'm trying to balance this, the first thing I might say is there's a lot more oxygens on this side than there is on this side. I wish there were more oxygens on this side in order to get this to balance. But that's really kind of tricky because I got a 3 here, I got an 8 here. You know, I can't just multiply this by a whole value and make it 8 in order to get to here. But that's really tempting because this is the only guy over here that has oxygen. So I can really manipulate all the oxygen on this side by multiplying this coefficient. And I'm ultimately going to have to. I have to add more oxygens over here and I have to change this coefficient. It'd be really nice if I could make that coefficient 8/3. Because 8/3 would give to me to the 8 oxygens that I need. I'd divide this by 3 and multiply by 8, and I would get to that 8 oxygens. And the important thing and I want you guys to realize is you can definitely do that. There's nothing wrong with that. You can just multiply this by a fraction, 8/3, and then clear that fraction by multiplying every term by 3. This is not too different than the way you might treat a polynomial in math. So I can clear the 3 out here by multiplying everything by 3. So I'm going to multiply the assumed 1 here by 3, get 3 copper. 8/3 times 3 just becomes 8. I've got a 3 over here. I've got a 3 over here, 3 here. And then when I start to do out my math of what I have for reactants and products, I'm pretty happy with what I see here now, actually. I've now got balanced copper. I don't have balance for my hydrogens. I'm still missing a little bit here. I don't have quite the balance for the nitrogen yet. I do have balance for my oxygens now. Now, the things I need to change are going to be hydrogen and nitrogen. And I want to focus on this side now to do that. And I want to do that because over here, my hydrogen and nitrogen are all in this one guy. So I can't manipulate them individually, right? But over here, I have just hydrogen on this guy and I have just nitrogen on this guy. So I can change these in order to raise or lower just the amount of hydrogen and just the right amount of nitrogen. And that's really what I need to do because I need more hydrogen. I need that to go up and I need less nitrogen. I have too many of those. All right. So what I would tend to do in this circumstance is to just lower this value, make that a 2, and increase this value, make that a 4, and then recalculate and see where I am. And as it turns out, when I do that, when I make this a 4 and this a 2, and I go through all of my math again, I actually do get balance. So whenever you're being asked these questions, it's important to remember that this is a balanceable equation. Like, it's not really super tricky. In the lab, sometimes you wind up with ones that are really tricky. But in these questions, they're really kind of rigged to work out. So you kind of try and follow your instincts and keep in mind what it is that you're trying to get more of or less of, and play around with these values. And with a little bit of clever guessing, you can usually get even a hard one like this to balance pretty quickly.